this video, we are going to explore the repulsive nature of gravity. Here you can see how matter fits into the space-time. First, we can check what we know about gravity. After, we can develop the ideas of repulsive nature of gravity from it. So we can jump into the video. For gravity, we have two important theories. One was presented by Sir Isaac Newton and the other was by Albert Einstein. In his theory, Newton proposed gravity as a pulling force. Einstein proposed gravity as the curvature of space-time caused by mass and energy. In his equation, he showed us the curvature of space-time on the left side and the distribution of energy on the right side. Every activity in our universe depends on the energy distribution in space-time. All objects in the universe interact with each other by gravity. So gravity must be a force of attraction or repulsion. Newton shows us gravity as an attractive force. Both of these theories explain gravity of a system. Whether gravity is a pulling force or a repulsive force, we do not care. We want to identify the features of gravity anyway. We are considering each object as a system. We are considering the curved space-time of each mass. So this model is explaining about the curvature of both masses in a collaborated system. In our present concept, the massive object is in the center of the gravitational system. The other masses are secondary in the system and are obeyed to orbit the huge mass. Here we are trying to describe more about the curved space-time of the secondary mass. In any model or any theory, we cannot say gravity is not a force. One can say gravity is the curvature of space-time caused by mass and energy according to the general theory of relativity. But the inner meaning of this theory states that gravity as a force, because the energy and gravity are related together. So in any form, gravity is acting as a force. I already stated gravity as a fellow traveler of energy, which cannot be separated from each other. The Earth's gravitational force is calculated to be 9.8 meters per second square, according to the Newtonian gravitational theory. We now have a more detailed idea of gravity through Albert Einstein's theory of general relativity. Yet we are confused about the repulsive nature of gravity. Let us examine it in detail. Here I am considering each mass an independent system which has its own curved spacetime. So it can create a repulsive gravitational field when it is collaborating with another mass according to its distance. Here I am trying to describe more about a curved spacetime of a collaborated system. So I wish to think more about the repulsive nature of gravity by both these two theories. Everything in the universe is energy and spacetime. We have been trying to learn about energy since the beginning of our history. We still do not understand the full benefits of energy. We still have a long way to go. We need to understand the boundless potentials of energy. I would like to remember you that even the food that we eat is also sunlight. That is, the plants store energy itself from the energy of sunlight by photosynthesis. Herbivores consume the solar energy stored by the plants by eating plants. By eating these creatures, we are also eating the same solar energy. Now we can convert energy from one form to another. Yet we have not been able to fully utilize all of this. I think it is time to look into the possibility of turning one atom to another. I start to think a lot about gravity and the curvature of space-time. Most of the pictures we saw in the internet demonstrate the curvature of space-time in a flat space. Here we can see that time is flexible to any dimension with the direction of force. In general relativity theory, we can see the flexibility of flat space-time. The reason for gravity in relativity theory is curvature of the space-time due to the mass and energy. In this theory, Einstein described the curvature of a flat space-time. Space-time was flat in his special theory of relativity. In the general theory of relativity extends the flat space-time into curved space-time. Space-time is not flat. It is flexible and variable in all dimensions. Energy is always concentrating on the center of the system and gravity is spreading around it. So there it can create only an identical space-time with all the directions. Gravity is holding the space-time to the center of the mass and the mass can freely stay in the space-time. In this geometry, gravity allows the mass to hang in the space-time. It is revealed that the space-time is holding a mass in it by the effect of the gravity. In my previous video, The Unification of Dimensions, I explained how space and time are distributed according to energy. I will add the link in the description box. This picture shows us how a mass can hang in a flexible space-time. Every mass has its own gravitational field. So we can say every mass in the space-time can create a curvature in the space-time. We can imagine our solar system, and we know that it is a complex gravitational system. The major part of the mass of our solar system is concentrated in the Sun, and all the planets are orbiting the Sun. So like the Sun, every planet can create a curvature in the space-time according to its mass. Up to this point is explained in the General Relativity Theory. As I said above, space-time is flat in General Theory of Relativity and mass can create a curvature in it. But in our concept, according to the above picture, mass is hanging in the space-time by curving it by gravity in all its dimensions. And our space-time is not flat at all by the structure. So we can see how space-time and energy interact in the universe. To understand the universe, we must first understand how energy exists in the space-time. For that, we need the ideas of Albert Einstein. Energy is located in the space-time in the same pattern he used to describe the gravity. So I wish to explain the concept of a curved space-time in the General Relativity Theory that I understood in my observations in a way that everyone can understand. In my vision, space-time in the General Theory of Relativity is flexible. The flexibility allows the space-time to curve following the effects of the distribution of energy on it. Thus, energy can pull space-time closer to it from all its sides. This energy can hang in the space-time which it has pulled into it. Thus, energy and space-time are always subject to interact with each other. For a better understanding of this theory, you can imagine the space-time as the surface of an ocean. Imagine that you are traveling in a boat in that ocean. You can observe everything in the General Theory of Relativity at that ocean. There are waves, the curvature of the surface of the water by the mass of the boat, the shape of a vortex that we can compare to the even horizon of a black hole, and much more. We can have a very clear view of Einstein's space-time concept from the surface of ocean. We can see that the surface of ocean is flat. So I would like to say that it is a two-dimensional surface. We know that mass of the boat can create a curvature at the surface of the ocean. When we are having this scenery, we are having the vision of a three-dimensional effect in a two-dimensional space-time. Now imagine that the boat is sinking into the ocean. Here we can observe the three-dimensional space-time of an ocean, and all the parts of the boat are under the curvature of the ocean. In a flat space-time, Einstein's theory of relativity is giving us a three-dimensional vision of a two-dimensional space-time. We are having an extra dimension here. When you are in the boat, you are adding your mass to the boat, and it is applying the total mass to the surface of the ocean to create the curvature according to the total mass. Here the bottom of the boat is having direct contact with the surface of the ocean, while you are not related to the surface of the ocean directly. Same as when a spherical mass is acting with a two-dimensional flat space-time to create a curvature in it. The bottom part of the sphere is having only direct contact with the space-time. The upper part of the spherical mass can't create a curvature in the space-time. Imagine that you have a sheet of paper and a small ball in your hand. You are trying to wrap the ball with the sheet of paper. You can wrap the ball, but you can't do it perfectly because the paper will create some folding while it curves according to the ball. When the spherical ball or the boat sinks in the ocean water, there we can have the three-dimensional space-time and it can easily wrap the spherical ball or the boat. If we ignore the gravity of Earth in this system or the ocean, the ball or the boat will not move into the bottom of the water. Somewhere in the water it can create a sufficient place. This is what happening in the space-time. Like this, all the objects in the universe, including our Earth, exist in a state wrapped by the space-time. Energy from all its dimensions bends space-time into it and hangs on it. There is now a general understanding of the interrelationship between space-time and energy. This condition is the cause of gravity. All these things are well described in the book Key to the Secrets of the Universe. Even though you can visit our website for more information. The connecting link for the book and our website is in the description box. If you are interested in it, you can find it. Now we can come back to our solar system. At this stage, we can say that the planetary motion around the Sun is due to the curvature of space-time. In this system, the Sun is curving the space-time to the direction of the solar mass, and the Earth is curving the space-time to its own direction. So we can see that two different spacetimes are curving in opposite directions. Two different curved spacetimes in the opposite directions can create an orbit around the stronger spacetime. But the position of Earth is inside of the curved spacetime of the Sun. So inside the curved spacetime of Sun, the Earth is creating another curved spacetime towards its position. So gravity of each object is according to the direction of mass. If we take two objects in space, their gravity is in opposite direction. This system allows even smaller objects like asteroids to orbit the Sun in the spacetime. We know in our solar system, Jupiter is the biggest planet and the Pluto is the smallest. But Pluto is orbiting the Sun even if it stays away from Jupiter. So even if the Earth's position has been changed in the solar system, it can orbit the Sun. Here we can see how gravity is creating a repulsion between two masses. Actually, the curvature of space-time in opposite direction is causing the repulsion. To get a better experience, we can imagine this picture, the gravitational system. This image represents the position of Earth in the solar system. In this picture, the Earth is located within the Sun's curved spacetime. But the spacetime curvature that the Earth itself creates is in the opposite direction. Similarly, the Moon creates its own spacetime within Earth's spacetime. So we can clearly say that the gravity of two objects are in opposite directions. So if we fully understand the properties of gravity, we can swim in it just as a swimmer can swim freely in the water. Thank you for watching our video.